My name is Sumit Chandrakar, and I'm a systems architect here at RTI. Welcome to the next chapter in the RTI eLearning program. Because performance testing is such a common activity, RTI has created a utility called PerfTest to help you measure the baseline performance of RTI Connext on your target systems. Today, we're going to discuss performance testing with this PerfTest utility. We'll discuss the architecture of the test, and then we'll go through the exercise of building and running the PerfTest. Prior to this lesson, you should know the basics of RTI Connext, the various entities such as data writers and data readers, how to compile RTI-based applications, and basic QoS configuration. We'll start with a high-level overview of the PerfTest, where you'll learn about the motivation for the test, the data flow, and how measurements are collected. Next, I'll go into the implementation details so that you understand the specific RTI data flows and how the test configuration influences the behavior and the results. I'll then show you how to build the test executable as we ship the source but not binaries. If you've already built applications that use RTI Connext, the build process should be relatively straightforward. I'll then demonstrate how to run the test itself. We'll also see the output from the test execution, and I'll explain how to interpret the results. Next, I'll show you some of the more common configuration options when running PerfTest. Don't worry if you do not understand everything here. There is a manual that contains a description of all of the arguments. It can be found in the PerfTest installation. Lastly, we'll talk briefly about troubleshooting PerfTest as well as where to find more information. So let's get started. One of the first things users do when working with RTI Connext is to evaluate the performance of RTI in their target environment. Machine, network, and applications can all be different, so we always recommend that our users measure performance for themselves. This can be to validate expected performance, to verify network behavior, or to evaluate the potential performance on a target system. To help them with this goal, we provide users with a testing utility called PerfTest that measures throughput and latency using the RTI Connext middleware. The test is shipped as a source so that users can alter the test behavior if needed, though we find that most users never need to modify the source. PerfTest is designed to be highly configurable so that you can alter the test behavior as needed. For example, you can measure performance as a function of the data size and rate. Quality of service policies, such as reliable versus best effort, can also be configured to measure the impact on performance. PerfTest lets you answer questions like, for a given publishing configuration, such as queue sizing or batch settings, a given message size, and a given subscriber configuration, again, queue size, listeners, wait sets. What's the throughput on my network? If my network is heavily loaded, what latency can I expect? For a given configuration, what is the best case latency with no other traffic on the network? These are the types of questions that we use PerfTest to answer. In fact, we at RTI use PerfTest to generate the performance results you'll find on our website. As I mentioned earlier, because of machine differences, you may not obtain the same results as we show on our website. We've worked with users that have observed much better performance, for example, using faster hardware and 10 gigabit networks, as well as users that have observed slower performance. PerfTest consists of two actors, publishers and subscribers. Note, from here on out, when I use the term publisher, it means a publisher PerfTest instance. And for subscriber, it means a subscriber PerfTest instance. It does not refer to the abstract notion of publishers and subscribers that we commonly reference in Connext material. A PerfTest publisher writes data as fast as it can. Each message, in addition to the payload, contains identifying data such as a sequence number and writer identification. This is so the messages can be properly sequenced and any drops can be detected. PerfTest subscribers receive the data from publishers. Every few messages, the publisher will send a special message requesting an echo from the subscriber. This message includes a timestamp that the subscriber will reflect back to the publisher. Upon receiving this echo reply, the publisher can calculate the round-trip latency. So why do we measure round-trip latency? Because we want to use a consistent clock for all measurements. If we attempted to measure the one-way latency in the PerfTest subscriber, we'd be subject to any differences in clock synchronization between the publisher and the subscriber. Given that latencies can be as low as single-digit microseconds, a small clock difference can dramatically alter the results. Thus, we calculate the round-trip latency using a single clock, the publishers, and divide by 2 to determine the one-way latency. As you can see from the diagram, publishers measure the latency using the request echo exchange. The publishers provide a histogram of latency measurements throughout the test, such as mean, standard deviation, min and max, and other things. We'll see more about the results later in this lesson. Subscribers calculate the received throughput using the message flow from the publisher. The subscriber provides throughput in samples per second as well as megabits per second. The throughput measurements are based on the configured data size and do not include any overhead from the RTPS protocol. Thus, PerfTest measures both throughput and latency, sometimes called loaded latency, which is latency at a given throughput level. PerfTest also supports a one-to-many topology, which means you can add more subscribers to the test execution. At RTI, we've used PerfTest with hundreds of subscribers receiving data from a single publisher. You can get the PerfTest bundle from the example pages of the RTI website. If you go to www.rti.com/examples and you look for the performance test, which is combined latency and throughput performance test for RTI Connext. PerfTest is implemented in C++, Java, and .NET or C#. The test is interoperable, which means you can test a Java publisher and a C++ subscriber or vice versa. We also ship it for Linux and Windows. We've also run PerfTest with other architectures, including Mac OS X, and embedded operating systems like VxWorks and Integrity, though we don't ship the build scripts for these platforms. Please contact us if you'd like help building PerfTest for architectures not listed above. Now we're going to go into the implementation details of PerfTest. PerfTest is designed to be extensible. Thus, it is implemented as a harness and a plugin. The harness is middleware agnostic, though we only provide a plugin for RTI Connext. The harness controls execution of the test for things like coordination and synchronization, ensuring the test actually starts correctly, sending data per the configuration, data sizes, data rates, etc., and retrieving and processing latency echo requests. The PerfTest is compiled into a single binary executable. That is, there is no need to compile a separate publisher and subscriber version of the test. The arguments to the test execution determine whether the PerfTest will start in the publisher or subscriber role. We ship the PerfTest with a plugin for RTI Connext. The harness asks the plugin to create the producers and consumers used in the test. In this case, each producer maps to a Connext data writer and consumers to Connext data readers. So what data flows are used in the test? There are 3 topics that the harness asks the plugin to create. The throughput topic is for the message flow that will be used to measure throughput. Since the publisher PerfTest instance sends this data, it creates a data writer for the throughput topic. Conversely, the subscriber PerfTest instance receives this data and thus creates a data reader for the topic. As the subscriber receives this data, the subscriber can effectively measure throughput. The latency topic is used for the echo replies the subscriber sends back to the publisher after receiving a latency ping. Thus, the subscriber instance creates a data writer for this topic as it must send this latency data. Conversely, the publisher PerfTest instance receives the echo replies and thus creates a data reader for the topic. Lastly, the announcement topic is used for test synchronization and coordination. For example, the publisher will not start sending throughput data until all of the expected subscribers have been found. This synchronization is based on the announcement topic. When a subscriber starts, it sends a single message announcing its presence. The publisher uses this information to decide when to start the actual test. This topic removes the need to worry about startup order since the publisher will not start until all subscribers have announced their presence. Note this is a synchronization mechanism independent of RTI Connext discovery because the harness is designed to be middleware agnostic. The data type used for all topics is a simple structure called testdata_t. The IDL file can be found in the installation directory under the IDL directory. The data fields include a key field, which by default does not include the @key designation, meaning the data type is not keyed for any topic. To make PerfTest use keyed data instead, you'll need to modify the IDL file or provide the appropriate compiler directive. More information about this can be found in the PerfTest User's Manual. A field identifying the source of the message is next, the entity ID. A sequence number used for ordering messages and detecting any loss is the sequence number field. We next see 64 bits for the timestamp, represented as separate seconds and nanoseconds fields. The publisher puts the timestamp in these fields. When the subscriber echoes the packet, the publisher can calculate the round-trip time. Latency ping is used for latency measurements. bin_data, which is an opaque buffer for storing the data that will bring the message up to the desired size. For example, if the configured message size used in the test is 1 kilobyte, the bin data will contain a bulk of data such that the total message size becomes 1 kilobyte. Building the source should be relatively straightforward if you built applications for RTI Connext. Even if you haven't, we provide makefiles to simplify the process. You'll find makefiles for C++ on Linux, Visual Studio solution files for C++ on Windows, and a build.xml for Ant if building for Java. There are also solution files for .NET, C# on Windows. I'm going to open up Visual Studio and show you how to build PerfTest. Before I do that though, please make sure that you set the NDDS home environment variable prior to compiling if you're following along. First thing you'll see here is I have a folder open to the RTI PerfTest zip file. After I've extracted it, you'll see the directory structure that you see here. There are a number of solution files present. Since I'm going to be building for Visual Studio 2008 and a 32-bit platform, I'll open PerfTest-VS2008.sln. There are also solution files for Visual Studio 2005, as well as 64-bit versions if you're building on 64-bit platforms. So I'm going to open up Visual Studio 2008. And you'll see there's a project called PerfTest_CPP-VS2008. This is the PerfTest project for C++. And I'm going to go ahead and build this project. You'll note there are two other projects, the types managed and the PerfTest_CS-VS2008. These two projects are for .NET platforms. If you're building for C++, you don't need to worry about building these projects. Conversely, if you're building for C#.NET, you don't need to worry about the C++ project. So as you can see here, my test built correctly. And the first thing you'll notice if we go back in the output is that the PerfTest script for the Visual Studio solution file will run RTI DDS gen to generate the support code needed for the test execution. And this support code is generated from the IDL file, which we find here, test.idl. Now the test executable itself can be found in the bin directory, again at the top level of the PerfTest installation. Inside of this bin directory, there will be an architecture-specific directory, in my case i86 Win32VS2008. Inside of here will be a release type. In my case, I'm building a release version in Visual Studio, so therefore you see a release directory. And inside of here, you see the PerfTest_CPP.exe. So our executable is put into the bin architecture release directory. Now I'm going to build PerfTest on my Mac OS X. You'll note that the build for Mac is quite similar to building on Linux. So once again, I navigate to the top level directory containing the PerfTest installation. Then I'll go to the PerfTest CPP directory and build the test using make. There are several make files here, each architecture specific. Since I will be building for my Mac, I will be using the x64 Darwin 10 make file. If you were building for Linux, you would use one of the other make files. So I'm going to kick off the build. And as with Visual Studio, the first step is to generate the support code for our data type. Now, once this finishes compiling, you'll see that if I go up one level back to the top level of the PerfTest installation, the bin directory contains the name of my architecture. If I go inside of this directory, you'll see there's a release subdirectory. And if I go inside here, you'll see my executable. So again, the executable can be found in the RTI PerfTest top level bin x64 Darwin release directory. I'm going to navigate back to the top level to start the test. Now, if you wanted to build using Java, you'll need to use Ant. I'm going to show you quickly how to build using Java on my Mac. If you don't get all the details, the PerfTest user's manual has more information. So to launch Ant, I use the executable Ant. I need to specify a build file. And as I mentioned earlier, we provide for you a build.xml file, which you'll find in the PerfTest_Java directory. You'll also need to pass a property file. Now we provide property files in a directory called resource property. And again, these are release specific. So in my case, I'm going to be building a release version of the PerfTest. And so it kicks off, and as we mentioned before, first thing, run the code generator, because this time we're generating code for Java. And as you can see here, the output in this case is a jar file rather than a executable. We do provide a convenient script for issuing or kicking off the PerfTest when you're running with Java. Again, the user's manual has more information. Now that we have the executable built, let's look at how to run the test itself. The test uses an XML configuration file for the baseline QoS settings. The XML file contains various QoS profiles for each of the topics in the test. Note that the QoS defined in these files isn't necessarily the actual QoS used in the test. Based on configuration properties, for example batching, some quality of service policies are made directly in the code. This file is located based on the paths relative to the current working directory. If the file isn't in the current working directory, the location can be specified via a command line argument. The test also uses an INI configuration for the testing parameters. This file must either be in the current working directory, or the location must be specified via command line argument. Testing options can be specified in the file or the command line, or both. Those properties specified on the command line take precedence over any values in the INI file. We'll go over some of the more common testing parameters in a few minutes. Now let's look at actually running the test. If no arguments are specified, the default configuration for the test is keep all reliability is used for the data flow, which means the test must deliver each sample and block when there are unacknowledged samples in the writer's queue. Multicast will be used for message delivery. The default addresses used are 239.255.1.1 for the throughput topic, 239.255.1.2 for the latency topic, and 239.255.1.100 for the announcement topic. All available network interfaces will be used by RTI. This has an impact on performance, as Connext will advertise each interface during discovery. This may lead to excessive packets on the wire. If you have more than one interface, it is suggested to specify a single NIC when running the test. The default data size is 100 bytes for the test. Batching is not used by default. The test is configured to run until an infinite number of messages have been sent, essentially running the test until explicitly killed by you, the user. The test is configured to send a latency ping every 10,000 throughput messages. So what this means is every time the publisher sends a message on the throughput topic, after the 10,000th throughput message, the next one will contain the timestamp indicating the echo request from the subscriber. Note the test by default starts as a publisher. If you want to start the test as a subscriber, you'll need to provide the -sub option. So let's look at what happens when we run the test. I'm going to go through a few examples of running the test and explain the results. I have two windows open, both in the top level directory of the RTI PerfTest installation. One command window here is my Windows virtual machine, and the other is a terminal shell on my Mac, which you saw when I was building the PerfTest. I'm going to run the publisher in the top command shell and the subscriber in the bottom command shell. The first thing I want to show you is the usage screen. This is what you see when we run PerfTest with the -help option. So again, running my executable using the correct directory structure, and I pass -help. You'll see the output contains all the options that you can configure via the command line or the INI file. You'll also see the default values for various arguments. So for example, the default data length is 100 bytes. Okay, I'm going to start my publisher instance first. I'm going to use the default configuration, which means I'll use no arguments other than the -pub option. The publisher instance starts and indicates that it's waiting for one subscriber, which you see here, waiting to discover one subscriber. Now I'm going to start my subscriber instance. And again, pass the -sub option to indicate a subscriber. Right away, you see the publisher finds the subscriber through the announcement and starts the test. You can see the output right away in the publisher, the instantaneous latency measurements. On the subscriber, which is the bottom window, you can see the instantaneous throughput measurements. Since I use the default configuration, the test will run until I kill the applications. I've stopped both instances of PerfTest. I'm going to restart with the command line parameters that will cause the test to stop after sending 100,000 throughput messages. I'll use the num_iter argument to cause this behavior. So here's my command line, and I use num_iter with 100,000. Again, the publisher starts, waits to discover one subscriber. And now I'll start my subscriber. Note that I don't need to pass any arguments to the subscriber because the publisher controls the execution of the test itself. Now, as we watch, you'll see that there are both instantaneous results, and once the test finishes, there will be a summary result. Finishing test indicates the test is done and going through the shutdown process, and you see the last line printed before finishing test is the summary results. So let's look at this output in a bit more detail. When running a publishing instance, there are two types of output, instantaneous and summary. Instantaneous results are printed each time a latency echo is received. You can see that the number includes the most recent measurement, the running average, the running standard deviation, and the observed min and max thus far. The summary results are printed after the test has finished sending all messages. These numbers are the histogram of the latency measurements, providing average, standard deviation, min, max, 50 percentile, 90 percentile, 99 percentile, and 99.99 percentile. The percentile measurements can be interpreted as X% of the measurements are less than or equal to this number. So in the results on this page, the 90th percentile means 90% of the observed latency measurements were less than or equal to 172 microseconds. The subscribing side measures the throughput and reports the results to the screen. The instantaneous results show the throughput measured over the last second, as well as the average measured since the start of the test. The throughput is reported both in packets per second and in megabits per second, where megabits is data size times messages received. The summary results show the throughput measured over the duration of the test, including the total number of packets received. Let's look at a few more test runs to see how the testing results can provide feedback about performance. So I'm going to run through a few more examples of PerfTest, just so you can get a feel for how configuration can impact performance. Let's look at a case with batching. I'm going to use a batch size of 1 kilobyte. So the exact same parameters as the last run. I'm going to start my publisher. I'm going to have it send 100,000 messages, but this time I'm going to add a batch parameter of 1024 bytes or 1 kilobyte. And I start my publisher. Now I'm going to start my subscriber. And note again, I don't need to specify any batch settings on my subscriber. In fact, I don't want to specify batch settings on my subscriber. The subscriber sends echo responses, which need to go out immediately after the publisher sends its echo request. If we use batching, those responses may be delayed, impacting our latency measurements. So therefore, we don't want to use batching on the subscriber side. As soon as I start the test, you'll note compared to the last time, it finishes almost immediately. We see one instantaneous measurement, and then we see the summary results. This is because batching reduces the overhead per message by packing multiple messages into a single network packet. Without batching, each published message is sent in a separate network packet. With batching, multiple messages are sent in a single network packet. This more efficient use of the network results in a significant increase in throughput without much impact to latency. Clearly, we need to have the test run for a longer period of time when batching is used, so I'm going to rerun the test, but this time send 1 million messages. So I'm going to alter my num iter parameter to instead take 1 million, and I'll restart my subscriber. We can see the impact on batching a bit more clearly now. Earlier when I ran the test, we were seeing 8 megabits per second, or roughly 10,000 packets per second. When I use batching, we see a throughput of approximately 79.1 megabits per second and a throughput of around 99,000 packets per second. So you can see the impact that batching immediately has on performance. One thing to note, my machine has several network interfaces. This can impact performance because the default behavior of RTI is to use all available network interfaces. I'm going to run the same test, but configure the test to use a specific NIC. So again, rerun with the exact same command line, but this time I will use the -nic option, and I'm going to use a specific NIC in my infrastructure. Note that I can specify a wildcard, which means I don't need to use the actual IP address. Again, start my publisher. This time I'm going to start my subscriber, and again, specify the NIC. And while there won't be a dramatic difference, you do note that there's a slight improvement in throughput. We've gone from a roughly average of 79.1 megabits per second to 82.5 megabits per second, from 98,892 packets per second average to 103,000 packets per average. From a latency side, we've gone from an average of 172 microseconds with a single NIC. With using all available NICs, we had 194 microsecond average, which is about savings of about 20 microseconds. So immediately you can see the impact of having multiple NICs and the influence on performance. There are several other variations of the test that you can run, all depending on your particular scenario. By varying the batch size, you can target a certain throughput level and then measure latency. The user's manual has more example command lines for running PerfTest. PerfTest is designed to be highly configurable through the command line. I've listed some of the more common arguments here, but there are several more that are documented in the manual for the test itself. Remember, these arguments can be specified via the command line or in the INI configuration file. The first 3 arguments in this table show the parameters that control message length, test duration, and latency measurement. The batch size argument controls the size of batching, if used. This is particularly useful when sending messages with a small message size, as we saw when I ran the PerfTest with batching enabled. The num subscribers and num publishers arguments are used to specify the expected number of PerfTest instances in a particular test run. Use read thread instructs PerfTest to use a separate thread for reading the data, rather than using the asynchronous listener callback. If you've watched the videos on listeners, conditions, and wait sets, you'll understand how the separate thread is used. Domain is used to specify the domain ID. The default is 59. The -nic option, as we saw when we ran the test, specifies which NIC or NICs to use if multiple are present. The argument is followed by the IP address of the NIC to use, with wildcards being allowed. The -no multicast option disables the use of multicast and switches to unicast only. Recall that what I mentioned earlier, by default, multicast is enabled. The -enable shared memory option enables the shared memory transport for the test. By default, PerfTest disables the shared memory transport and only uses the UDP-v4 transport. If so desired, the shared memory transport can be enabled. This is particularly useful if you are running PerfTest on a single node and don't want to use the network. The -latency test runs a specialized version of the PerfTest that will focus on latency by using a ping-pong approach. The publisher will send a ping to the subscriber, which will respond back with the pong, aka an echo. In normal PerfTest, the publisher is sending throughput data along with these latency pings. The subscriber is receiving the throughput data and then replies to the pings as they are received. With using the -latency test version of PerfTest, the publisher is only sending latency pings and no other data. In fact, the publisher does not send the next latency ping until an echo is received for the previous message. This is a more deliberate latency test that measures latency exclusively, as throughput will be quite poor for such a flow. With any test, particularly performance tests, there may be issues during some of your test runs. The RTI knowledge base has a wealth of information about common Connext solutions independent of the PerfTest. However, there are some common concerns we've encountered when running PerfTest at customer sites. Things like discovery not completing between the publisher and subscriber. This is usually caused as a discovery issue and may be caused by things like multicast not being available or properly routed. Remember that discovery uses multicast by default and the PerfTest uses the default discovery configuration. Performance problems caused by mistuned socket buffers are a problem as well. This is a common problem for high-performance applications on many different operating systems. The RTI knowledge base has information about Windows registry settings and Linux kernel settings that can improve the performance of network traffic. Connext will use all available NICs unless otherwise configured not to. Because of this, multiple network packets may be generated each time a message is published by a data writer. This will necessarily slow down performance, as we saw when I ran the tests on my machines. To avoid this, be sure to specify a single NIC. Sometimes the I/O impact from printing the instantaneous results can affect the performance through no fault of Connext. This can be avoided by using the noPrint argument so that instantaneous results are not printed. The summary statistics will still be printed as these are displayed after the test execution finishes. There's plenty of additional information, including some common kernel settings in the user's guide of the PerfTest installation in the doc directory. So let's review what we've covered here. We first took a high-level look at the architecture of the PerfTest to explain how it can be used to measure both throughput and latency, or load of latency. We then dived a bit deeper into the implementation and went through the process of building the test, running the test, and interpreting the results. We had a brief discussion around some of the more common options for controlling test behavior, with the complete list, of course, being available in the documentation. Lastly, we had a brief look at some of the more common problems users encounter with their first run of PerfTest. Hopefully, you should feel a little more comfortable downloading and running PerfTest for yourself. I encourage you to try this out, even if you're confident that Connext can provide the necessary performance. Sometimes it's good to know what your infrastructure will allow, even with something like Connext in the system. If you'd like to explore further, try to link the RTI monitoring libraries into the PerfTest and then run the RTI monitor. You'll gain valuable insight into the behavior of the RTI Connext reliability protocol, as well as observe some of the QoS settings that are used for high performance. These types of QoS settings may be useful for your own application needs. I'd like to thank you for taking the time to watch this video and wish you the best of luck in your endeavors with PerfTest. Remember to never hesitate to ask if you have any questions. We at RTI are always ready to help.
Thank you for watching this portion of RTI's online training, focused on RTI Connext DDS. We'd also like to remind you that there are additional resources located on our eLearning webpage at www.rti.com/elearning. We also invite you to visit our community portal, where you can post general or training-related questions and receive answers to those questions. Lastly, please feel free to send an email with your questions or comments to elearning@rti.com. Again, thank you for watching and have a great day.